Okay, assalamu alaikum once more. This is Abdi Muhammad Nur, who will be taking for you chemistry of Form 1. Today we are going to discuss about reaction of hot cobalt dioxide with hydrogen gas. Bear in mind please that this thing is very examinable. In chemistry, remember, we don't cram things, we understand and move ahead. So the moment you will be learning metals, extraction of metals or electrochemistry in Form 4, you must have this concept in brain. The reaction of hot cobalt dioxide with hydrogen gas. You see now, the question here is, why are we saying hot cobalt dioxide? Why are we not saying cobalt dioxide? That's the question. Copper is already undergone what? Oxidation. Just understand. And copper is very low in the reactivity phase. So it has to be activated. It requires energy of activation, activation energy, sorry. It requires activation energy. So that's why we are saying hot cobalt dioxide. You see now? So now the question here is, what will be the observations that you're going to make when hot cobalt dioxide will react with the hydrogen gas? Okay? Then what will happen to cobalt dioxide? And what will also happen to hydrogen gas in the process of reaction? In the process of reacting these two, what will happen to cobalt dioxide and what's going to happen as well to hydrogen gas is what you're supposed to know, guys, in high school. Okay, before we react hot cobalt dioxide with the hydrogen gas, there's one condition that must be fulfilled, and that condition is we must drive out any air that is initially found in the combustion tube. Why? Because, or in the jet, you can also say in the jet, yeah? Why? Because in pure hydrogen, when reacts with oxygen, it will cause what? Explosion. You see now? So we must drive out the initial air in the combustion tube. In the examination, you can be asked, explain why the air inside should be driven before reacting hot cobalt dioxide with hydrogen gas. Because the air inside will form a mixture with hydrogen, yeah? Because remember, we are passing a stream of dry hydrogen gas over heated cobalt dioxide. So we need the pure hydrogen that will react with the oxygen from cobalt dioxide to form a colorless liquid called what? Called water. Don't forget that. Chemistry is a matter of understanding. He who tells you crime chemistry or copy from the KLB, that person is actually taking you to the bush. Yeah? It's misleading you. He or she is what? It's misleading you. Chemistry is a matter of understanding, guys. And I'm sure if you go with me up to the end, I'm sure you'll enjoy life in chemistry. So that is the first thing. Then we are going to explain and we'll give you the note, God willing. Just understand the explanation, because you can go to the respective KLP book, format, and just read again once more to see what we are saying here, whether it's true or false. Remember, this is what we are having. We are going to pass a stream of dry hydrogen gas over heated cobalt dioxide. So the reaction will be like this. Cobalt dioxide plus hydrogen gas. So the end product will be, let's get the product, because these are the reactants. Cobalt dioxide plus hydrogen gas. It will be copper metal plus water. This is what we normally call one equation. And every student in high school, whether he or she is in Form 1 or in Form 4, it is must that you know how to write word equations, because they are very helpful. By the way, you cannot write chemical equation without knowing the word equation. And you must know what's reacting and what will be the product. You must know. If you cannot differentiate those two, then may God bless you. Yeah? Make sure you catch up with us. So when cobalt dioxide reacts with the hydrogen gas, copper metal and water will be the end product. So let me write the chemical equation here. Copper is a metal, so write solid. Copper is what? It's a metal, so Cu. Then this solid plus hydrogen gas is going to give us what? Sorry, it is cobalt dioxide. I apologize. It is cobalt dioxide. Remember, all metals and metal oxides are solid. That's what they normally call the state symbol. Copper 2 oxide is solid. It's metal that has undergone what? Oxidation. Plus, what are we adding? Plus hydrogen gas is going to give us what? We say copper metal, which is solid, plus water, which is liquid. Okay, in the examination you can be told, write 2 observations in this reaction. Write 2 deductions or 2 observations that can be made from this kind of reaction. In the examination you can be told like that. Remember, this copper 2 oxide is black in color. It is what? It is black in color. When it is copper 2 oxide, yeah? Here it is red brown. Red brown. So can't you see now this color change? Okay? Now the 2 observations we are going to make here is that black copper 2 oxide will be reduced to red brown copper metal. So copper 2 oxide is undergoing what we normally call reduction. Copper 2 oxide is undergoing what? Reduction. Now the oxygen that has been taken out from copper 2 oxide is reacted with hydrogen gas to form what? Water, which are colorless liquid. So another observation here is formation of colorless liquid, which is what? Which is water. We will go ahead and see the test of this liquid, yeah? Don't worry about that. Whether it's liquid or any other liquid, yeah? Whether it's water or any other liquid, we are going to test it. Now the 2 observations made here is that, look here, observations made. Observations made. Let's see that. Black copper 2 oxide. Black copper 2 oxide is reduced to red brown copper metal. Period. That is observation number 1 or reduction number 1. Black copper 2 oxide is reduced to red brown copper metal. You see now this color change. Just understand. Okay, another observation here is that a colorless liquid, which is water is formed. Which is water is formed. A colorless liquid, which is water, is formed. This is another observation. Okay? Hope you are digesting this thing. It's very easy. Black copper 2 oxide is reduced to red brown copper metal. One observation made. A colorless liquid, which is water, is formed. That's another observation. Okay? That's another observation. Okay? Now, we are going to learn some terminologies. Reduction. Let me start from here, because it's reflection of light, I know. We are going to define this one. Reduction. Now, what's reduction? Reduction is the removal of oxygen from a compound. Let's write that. Is the removal. Is the removal of oxygen from compound. Period. Okay, now, which of these two is undergoing reduction now? Copper 2 oxide and the hydrogen gas. Copper 2 oxide, which was black in color, was reduced to red brown copper metal. So copper 2 oxide is undergoing what? Reduction. Let's write that. You see now, when we say, let me write it here, copper 2 oxide, which is solid, plus hydrogen gas, we said it's going to give us copper metal, which is solid, plus what? Plus water, which is liquid. So copper is reduced to copper metal. Look here. Copper is reduced to copper metal. So it's undergoing what? Reduction. It's undergoing reduction. Because hydrogen is removing oxygen from copper dioxide. So copper dioxide is reduced to copper metal. And when you look at hydrogen now, hydrogen, what has happened to hydrogen? Hydrogen has been added to oxygen, meaning we have oxidized hydrogen. So hydrogen is undergoing what? Oxidation. Look at this. How chemistry is very fair and very easy, by the way. This is very nice subject, by the way. Oxidation. Oxidation means we have added oxygen to hydrogen, so we are oxidizing. Which one is oxidizing? Copper is oxidizing what? Hydrogen, because it's adding oxygen to hydrogen. So hydrogen is undergoing what? Oxidation. Understand that? So what's oxidation? Oxidation, let's divide that. What's oxidation? Is the addition of oxygen to a carbon or to a substance. Or to a substance. Let's say that. Or even you can say to a carbon, yeah? Yes. To a compound, you can say that. Or you can even say to an element, yes, because hydrogen is an element. Okay? So it's the addition of oxygen to a carbon. So now we are adding the oxygen which has been removed from copper dioxide is added to hydrogen to form a colorless liquid called water. Don't forget that. Okay? Now, look at this one. Now we have what you normally call, we have also what you normally call reducing agent. We have what? Reducing agent. In chemistry, reducing agent is a substance which reduces another substance. Like now, hydrogen is reducing copper dioxide to copper metal. So our reducing agent in this situation is what? Is hydrogen. Hydrogen gas is our reducing agent because it is reducing copper dioxide to copper metal. Can't you see that? We have also what you normally call oxidizing agent. Oxidizing agent. Oxidizing agent is a substance, is one which oxidizes another substance, meaning which add oxygen to another substance. So which one? Our oxidizing agent is what? Our oxidizing agent is the one which is undergoing reduction. The one which is adding oxygen to another element, to a substance. So now our oxidizing agent in this situation is what? Is copper dioxide. Because it is adding what? Oxygen to hydrogen. So this is copper 2 oxide. Copper dioxide. Please understand this thing. Reducing agent is the one which is removing oxygen from a compound. So in this situation, in this reaction now, which one is reduced? Which one is removing oxygen? Hydrogen. Hydrogen is removing oxygen from where? From copper dioxide. So that's our reducing agent. Which one is adding oxygen to another substance or compound? That is what? Copper dioxide. So copper dioxide is our oxidizing agent. So in chemistry, the species of the compound that's undergoing reduction is your oxidizing agent. And the one which is undergoing oxidation is what? Is your reducing agent, for your information. Get that point clear, please. Okay, then we are going to see the test of this colorless liquid which is formed. The test of this colorless liquid which is formed is what we are going to see. Test of the colorless liquid. Test of the colorless liquid. That's what? That's water. We are talking about water because the colorless liquid is what? It's water. Test number one is that uh, it turns white anhydrous copper 2 sulfate to blue. That's number one. If you add, anhydrous means what? Does not contain water. Hydrated means what? Contains element of water. So it turns the colorless liquid, that's water. It turns white anhydrous copper 2 sulfate to blue. Let me write that. To blue. Look here, the end product. To blue copper 2 sulfate. Let me complete for you this statement. This color change, it was white. When you add anhydrous copper 2 sulfate to water, when you add water to this anhydrous copper 2 sulfate, anhydrous copper 2 sulfate is white in color. It is what? It is white in color. So the moment you add water to it, or to this copper 2, anhydrous copper 2 sulfate, the color will change to blue. So you'll have what? Hydrated copper 2 sulfate, which is what? Which is blue in color. That is it. The liquid you are adding is water. That's the test for water. Don't forget. Another test is, this is test lab 1. It also turns blue cobalt 2 chloride to beam. Look here, copper 2 chloride is beam in color. It is blue in color. If you add water to it, then it will turn into beam. So those are 2 tests for the colorless liquid, which is water, for your information, guys. Don't forget that. Okay. Don't forget that. Then we will go ahead and see, after knowing the 2 tests for the colorless liquid, we will go ahead and see other compounds that can be reduced by hydrogen. Hydrogen has also the ability to reduce the oxides of lead and iron. Let me write that. Hydrogen has also the ability to reduce the oxides of lead and iron. What did I say? Let me write that. If I write now lead 2 oxide plus hydrogen gas, you will have what? Lead metal, which is solid, plus water. You can also say iron 2 oxide plus iron 2 oxide, plus, which is solid, plus hydrogen gas. It's also going to give us iron, which is metal, plus what? Plus water. So this one is undergoing what? Reduction. Look here, it has been reduced to lead metal. This one is also undergoing what? Reduction, because it has been reduced to iron metal. Don't forget that. So hydrogen has the ability to reduce the oxides of lead and iron, just like copper 2 oxide. Into what? Into the respective metals and water. Don't forget that. So guys, this is what is going to happen when hot copper 2 oxide reacts with the dry hydrogen gas, for your information, or when a stream of dry hydrogen gas is passed over hot copper 2 oxide. I think I've tried my best. Make sure you go back and read your KLB syllabus, because it's gonna help you. Just read. So far you have the concept now theoretically. Make sure you go there and read for your information. Bear in mind that we should not be greedy. Make sure you share this concept of chemistry to your brothers and sisters, as well as your close friends who are also suffering at home level and stranded by COVID-19. Otherwise, I wish you the best. Make sure you subscribe. Don't forget that. Leave your comment and as well as send your problem via our YouTube channel. Otherwise, I wish you the best.